The result was 5,400. This was 2 times the expected number. What was the expected number? This is algebra. They're actually, they're making it pretty straightforward, but it's algebra that you're writing up the equation. So what do you think? How would you write it? 2.5 times the expected number, the result. Now they wrote this in different order. Yeah, they could have written in the exact order so that you can write it like exactly that order, but it doesn't have to be. What do you think?
2.5 times x equals 5,400.
Yep, that's it. You can do 2.5 if you want, but I believe they want you to actually convert. I have a feeling they want you to convert. That's it. So you're trying to find the expected number. The result is 5,400. You okay? Yeah. Let me see what that looks like. 2 times 2 plus 1, that's 5 over 2. X equals 5,400. So multiply the reciprocal, 2 over 5 times 2 over 5. Yeah, so this can be cross-cancelled. So I'm actually going over the second number here. So x, anyway, 5 can go into 54. The 54, how many times? This is the 54, 9 times? How many times? Is it 9 or is it something else? Is it possible? No, but it will go into the whole thing, right? Like you want to see if you can't do 54, you can do 5,000, 1,000 times. Do you see 5,000? And then 5 can go into 400. How many times? 80 times? Is that right? Yeah, that's it. So it'll be the 1080 on top times 2. Let me double check my math. 54 divided by 5. Yeah, 1080. You see? Okay. Yeah, do you see how I actually thought that out? The 5,400 is made out of 5,000 and then the 400. So I do the 5,000 divided by 5 first, which is 1,000. Okay, and then the 400 divided by 5. So whatever that is, 216, 2116. I mean, yeah, 2116 should be the answer, right?
Yeah.
Okay, times 2. Yeah. All right. Next one. Number 2. Oh, write the unit. Oh, there's no unit. It's just a number. It's just a number. Interesting, right? Hey, no unit. It's just a number. There you 21. Your number is 2160. 2. Number 2. The ratio of students who took Spanish and who's the other one? German. Spanish to students who took German was 15 to 2. So I was going to write 15 over 2, but then I'll write S for Spanish and German for 2. G for German, S on top. Okay. But then if 3,000 students took Spanish, how many took German? Again, I recommend you set up the proportion, right? You want to tell me how to do that? Your teacher may not have been doing that. I don't know. So, but let me see. What do you think? How would you set up number 2?
15 over 2 equals 3,000 over x.
3,000 over x because 3,000 is the same row as students take Spanish, right? Yeah, that's it. So can I ask you, when you guys go over this type of problems, we've seen it at least 3 times already, like the proportion that I really push you to set up. Have your teacher be doing this? Could you tell me? Do you know? Right? You should be doing this because you guys been setting up equations, algebraic equations. So this is actually part of it. It's proportion. So you should be, oh, and similar triangles. Remember, you want to do similar triangles based off proportion. So that's why. So it got to be it. But again, some teacher will actually kind of, will be off track and do something else. That you could get the same answer that you've even shown it. Anyway, 15 times what will give you, I know you can do this, cross cancel, right? I guess you should. You could write it like that. 6,000 like this, right? And divide both sides by 15. But you can, yeah, whatever that is. 15 can go into 30 two times, but can go into 60 four times. Get it? So that means it'll be 4 and then the 2 zeros. Is that okay? You see how I got that? Like I see divide both sides by 15. But I know 15 can go into 30 two times, but this is 60, at least the first two digits. So we'll go into it 4 times, but then keep the remaining zeros. But yeah, it's okay. You can use a calculator and do long division. But here, I'll check it. Yeah, 400. Oh, and then write the units for this one. Students. We want to be specific to who took German. Students. Yeah, students. All right. You okay? Okay. 3. 7,700 biochemists made it on time. If the ratio of those who were on time to those who were late was 7-2, how many biochemists were late? Okay, what do you think? This is number 2. This is my number 3 here. I would go with the 7-2 first, right?
7 over 2 equals 7,700 over x.
So let's double check that. The ratio on time. This is on time. This is late. And yeah, you got it. You okay?
Yeah.
Yeah. Whatever this is, let's write a little bit. Oh, have a look, okay? So cross multiply to be 7x equals, have a look here, okay? This is what I've been recommending. You see why this is useful? Have a look right here. When you cross multiply here, you don't want to use a calculator to multiply this 2 and 7,700, okay? Write 2 parentheses 7,700 here. Why? Because if you divide both sides by 7, right? 7 can now go into this whole thing 1,100 times. You get that? This could be done all by hand. So you have to use a calculator or write a vertical multiplication. See how I'm doing it? And then 2 times 11 is 22. Then add the zeros. There's your final answer right here. But what is the unit? Biochemist. Biochemist. There you go. Late. I don't know. Parenthesis LT. There you go. But you see how why this is some fancy math here, okay? But it's actually very basic. But it's fancy because many students don't think it, at least in the early stages, right? But here I'll show it to you. 2 times 7,700. You may do this, right? And then you write that down, right? The 15,400 there. And then you want to divide that by 2. Oops. Divide that by 2. Same answer here. Wait, what did I do? I'm sorry, you multiply and divide it by 7. Sorry. Multiply by 2 and then divide by 7. Sorry. There you go. Same answer. Anyway, let's continue. You okay with that?
Yeah.
Number 4. I'll write it over here, I guess. All right. The late production of the machine was increased to 1,400 bottles per hour. So it's a rate. How many bottles could the machine produce if it operate for 8 hours? Now, this could be done with proportion, or it could be done just through reasoning, like how the unit multiplier method. But I'll let you dictate which way you want to do it. I recommend proportion because you've been doing proportion, but it doesn't have to be. But this one works perfectly for proportion because there's a unit for bottles and a unit for hours. And then the unit for bottles, it's asking also, like unknown, right? I don't know. You see, I'll let you set it up. I want to see how you would do it for number 4.
Okay, so it would be 1,400 bottles over 1 hour times 8 hours, and then you cross out the hours, and then you can cross multiply or cross
Yeah.
cancel.
So you're doing a unit multiplier. No problem. You wanna not forget how to do it. So let me write what you said here. So it's gonna be bottles here. I'll do bots, whatever, and 1 hour here. And you're timing it by 8 hours over 1. Yeah. Let's do it this way for this time. But realize you're not doing proportion, right? You're doing unit multiplier.
Yeah.
Is that okay? You're doing unit multiplier. So do that. So 8 times 1,400. So you get, here's your answer, 11,200. 11,200 bottles after 8 hours. There you go. Now, what I was gonna show you, look, number 4, before we move on, you could also have done it as a proportion. Have a look. So 4, you know why? Because you were doing equation. So let's see what this looks like in proportion. Have a look. So this would be 1,400 on top over 1 hour on the bottom. So even I'll do B for bottles now, and then T for time. I know, hours or whatever. Okay, have a look. And then if I were to do a proportion, since 8 is time on the bottom, that means the unknown, it says bottles, right, on top. There it is. You see it? Same answer. If you think about it, if you cross multiply, right, it'll be x times 1, which is x, and then 1,400 times 8, exactly 11,200 bottles. You get that?
Yeah.
So this is another way. I mean, I would have done it like this way right here, because you were doing proportion above it, right above it. And you were doing it quite a bit now. So to me, I believe they want number 4 to be done in proportion. That's my opinion. But you were also doing unit multiplier before this. Therefore, it's valid. You can do whatever you want. But don't forget, yeah, so you practice so you don't forget. How about that? So it's fine. Your teacher accepted. No problem. But I'm pretty sure number 4, it's intended for you to do proportion. Okay, don't forget proportion looks like this, okay? The way that you state it, it's a unit multiplier. So it's if it's not an equation like with an unknown, I mean, I know you're doing unknown equals like the answer, like multiply to get the answer. That's also an equation, that's true. But proportion, normally you don't get the answer yet until you cross multiply. But this one cross multiply, you get the answer immediately, of course. But the setup, it's what it's important about. Okay, I think okay. Right. What about 5? Let's see what this is about. A science fiction film earned 85 million. Okay, the unit is $1 million. So kind of keep that in mind. During its first 4 weeks at the box office, the weekly distribution of the earning is over here. That's it. Okay. Anyway, the question is, how much money did the film earn in its 3rd week? Okay. So you have to look into the chart for the details, right? At the box office. So what do you think? How would you do it? I think you can kind of think away from proportion now. Yeah, because when it's not necessary and it's short, there's like something concept on top of it, then you're okay to move away from it. When it's not like straightforward, you can move away from it. So anyway, just do it like the way you think you can do. How would you do it?
Um, um,
You have to read carefully, okay? Because it's more grammar. Actually, yeah, there's grammar that you have to break down besides math.
so you
So
do 85 million divided by 4 weeks.
well, it's actually easier than that. Read carefully, okay? In the chart, look, like look at the biggest portion. Week 1, it says 40%. Week 2 is 30%. Week 3 is 20%, and then the smallest week 4. This is actually common in
Oh,
if you think about it. Yeah, in
85 million divided by 0.2
let me see.
because 20%.
But why do you want to divide it by 0.2 though? Let's see. You got like the $85 million like for the whole week. That means the whole chart. I mean, sorry, that's the fourth week. Sorry, that's the fourth week. 4 weeks. Oh no, that's not true. It's the whole chart. Okay, yeah, it's not the word fourth. It's 4 weeks. So it's four. So 4 weeks. The whole chart represents 85 million. I don't know. You're okay with that? If you were to divide the 85 by zero point 0.2, you bloating up. Let me show you the math. You blowing up 85. You gain more than 85. So that means it's not true immediately. Have a look. So if you attempt to divide like the 85 million, have a look. I'm gonna punch in, but pretend it's in million, okay? But pretend this 85 is in million. Divided by zero point 0.2 is that yeah 0.2 for it will not be 85 anymore. It'll be more than 85. Have a look. So it's 425 million. That means now you're actually coming up with a number that supersedes 85. So no, it's no longer true because the chart represents exactly 85 million dollars in earning for the 4 weeks. So therefore, that's not true. So what do you think? Yeah, so I'm like kind of like showing you like the reasoning, like if you think it's the operation like divide it's correct, test it and see the answer. So before you accept the answer, make sense of it too. But I understand this chart is like you never seen it before, I don't think. But what it means that hey, 40%, meaning it's almost half of 85. That's what they earn first week. Get it? 85 million. That 40% first week, almost half of 85 they earn, whatever that number is. But the rest of it, total up 85. So what do you think?
Um,
So let me give you an idea. For example, 10%, like the fourth week, this is how much they earn. 8.5 million. So that's a hint. So the fourth week, like that little pie chart right here, it earned 8.5 million. So it's a small amount of 85 million. I think that's right though. Let me check it on the side with my phone calculator. I'm pretty sure it's right. But wait, okay. So tell me, so it's you cannot divide. What else can you do?
um,
Yeah, it's 85. It's 8.5 million for that week, that fourth week. Okay, so I'll help you here. So it's percent off. Percent off. Do you remember what math you do? It's percent off. Each one of those percentages, it's percent off 85 million. Week one is it's 40% off 85 million. Week two is 30% off 85 million. Week three is 20% off, and then 10% off. So what is, remember, fraction or percent off? What math do you do?
Times.
You times, but you don't times the percent, you times the decimal or fraction, remember? Yeah, if you ever see fraction, if you see like the way it's written, fraction, percent, and it hence off, it kind of tell you right here, if you read carefully, right? Weekly distribution of earning, the word off here, but I don't think you're gonna associate the word off like directly, like the way you've seen, hey, half of 100, half of 100 means one half times 100. 1/3 of a number, you times that 1/3, or percent off, you convert decimal into percent, and then a decimal percent into decimal, and then times to that big number. So yeah, so the math you do is going to be, don't forget we're doing the first week for, wait, what is it? How much did it earn in third week? Third week. So third week is 20% here. So it's going to be, I'll write the whole phrase. I'll write this first of 85 million. I'll do mil like that. Mil of the dollar, mil. So therefore, it's going to be 0.20 or 0.2 times 85. I'll do 0.20. I'll do 0.20. So whatever this is the answer. I'll do a placeholder there. So let's punch that in. 0.20 times 85. But it's going to be in millions, okay? So here it is. The answer is $17 million. So I'll write this time write the whole word million. I'll put the dollar symbol right up here. So there's your final answer. Is that okay?
Mm-hmm.
All right, let's see the next one. Number 7. Okay, oh yeah, here we go. We have a new concept. So tell me how your teacher have shown you this. And I'll show you like all the variations of it too.
So, if it doesn't have a line under it, you don't color in the circle.
Right.
You just do open circle,
Mm-hmm.
and since the arrow is saying that 6 is greater than, the arrow is going to go to the left.
That's right. You said the word greater than. Do you mean to say it that way? You mean something else? It is true that's, yeah, go ahead.
6 is...
Okay. The way I think your teacher intended is like you read from left to right. X less than. Yeah, every time you have inequality, make sure you read from left to right, right? X less than. Oh yeah, if you didn't familiarize yourself with like the greater than, less than, there's an easy way. Your teacher already give you like something fancy, like with the alligator teeth or something. I don't recommend any of that. Let me show you what. It's pretty simple. Later on, you probably don't remember what alligator, which way, whatever. You know what I'm talking about? Like the teeth? Because you can have the teeth in both directions, dude. Like facing that way or facing that way, whatever. It makes no sense to me, but take a look. This is less than, and this is greater than. Of course, you have a bar on the bottom, but ignore the bar for now. This one here, this one looks like an L. If you tilt it a little bit, the other one can never turn into an L. Think about it, okay? This one looks like a less than. If you tilt it a little bit, right, it looks like S. If you know less than, the other one's greater than automatically. Is that okay? That means so it looks like an L to me right here, and this does not look like an L, therefore it's greater than or equals to with the bar. So anytime you have inequality, make sure you read from left to right. In math, you should always trace from left to right no matter, especially when you graph. I know that we're graphing right now, but then when you're doing 2D graph, it's even more important. You have to find where it's increasing, decreasing, and all that from left to right. Left to right. You can't pick whatever you want. You'll see. We have time. I'll try to remember this because it's important when you interpreting from left to right in math, graph wise or inequality wise. Inequality, you're doing it right now. So it says x less than 6. Therefore, you're going to point that in that direction, like you said, right? But you start at 6, right? But how do you graph it? Do you put it on the number line? Do you put it above the line?
On the line.
Yeah, I would do that. So open the dot. Is that how you do it? Right?
Yeah.
Okay, that's it. This is the answer. I mean, some people will actually do more numbers right here. You know, like 5, 4, whatever to 0, and then wait, sorry, 7. But this is not -7. You know, and then you get your 5 and so forth. You can do something like that, and then get a 0 over here. You want right? There's your answer. Yeah. Now I'll show you more variation. Sometimes they use parentheses with the arrow. This is old-fashioned stuff, like this. See that?
Mm-hmm.
When when you have the bar, pretend there's a bar underneath here, right? They'll use a bracket and point in that direction. A bracket, okay, like the parenthesis bracket, like that. You could put it above the line, or you could put it on the line. Sometimes they put it below the line, but that means you make sure the numbers are on top. So it's kind of weird how they do this, but most commonly it's actually on the line. So that's how I would have done it, like that. Okay, number 8, same thing, right? You would point the arrow or start at -22, and then how would you graph it?
Since there's a line under it, you have to bold the
Yeah,
circle, like color
yeah,
circle.
color in and then shade in that direction. Now let me say something about this, okay? You could only point the arrow in the exact same direction as like the inequality arrow, you know,
Yep.
like if and only if the variable is on the left side. If you didn't know this, you should know it now. And I can prove that also. But right now, if your variable is on the left side of the inequality, you are allowed to graph it exactly in the same direction as that. If not, if it's on the right side, you have to shade it in the opposite direction. What do you mean on the right side? It could have been written like this, dude. Like number 7 could have been written exactly like this. 6 greater than x. Therefore, x is less than 6. Same thing. If you think about it, the reasoning, right? If a is greater than b, therefore b has got to be less than a. That's all. So you can flip it. But if your variable happens to be b, I recommend you flip it and then graph. If not, graph the opposite. You either memorize, graph the opposite. If x is not on the left side, then you can do that. Or if you flip it, then you can graph it exactly in the same direction it's pointing. So you flip it, it will look like this, right? Same thing. They mean the same thing. X less than 6, therefore 6 is greater than x. If you think about it, okay? That's reasoning. So, but if you were to graph on the number line, you know, one dimension, a flat line, I recommend you flip it, make the x on the left side, and then you could point the arrow exactly so you don't make mistake. But if some people have no problem with that, you can memorize it. If it's not on the left side, then point the arrow in the opposite direction. I don't know if you're okay with that. I'm making this up, okay? If 7 is actually greater than x, I'm sorry, less than x, I'm making this up. If 7 is less than x, then the graph will look like this. I'll do a bar. It will look like that. I'm shading in the opposite direction. But the reason because x is not on the left side. If I flip it, watch, if I flip it, it's exactly what you should be graphing. You see it? There it is. Right here. Okay, anyway, let's move on. I think you got this. All right. Use two unit multiplier for, or let's set this up quickly. We don't have to finish it. Number 9. How would you do it? Yeah. Number 9. Two unit multipliers to convert 1 million square meters to square centimeters. Oh yeah, you have a table conversion? Oh, conversion?
Oh no. No.
Yeah. Meters to centimeters. Do you remember how to do that?
So is it 1 million meters squared times 100 centimeters over 1 times 100 centimeters over 1?
Let me see. You said, give me the first one before timing. Or what was the first one again? Yeah, it'll be the same for the other one, of course. You
Times
said
100 centimeters over 1 meter.
100 centimeters, 1 meter, like that. Yeah. Is that okay?
Yeah.
And then you times another one here.
Yeah. And then, yeah.
Okay. Hey, if you ever, I think you have a table of conversion, right? If not, you can Google it. For example, something like this: 1 meter to centimeters. It populate that already, so you get 100 centimeters. You see that? Is that okay?
Mm-hmm.
Yeah, but it's right. I mean, what you said is right away. That's it. Whatever this is, yeah, multiply them, cross them out right here, and you're good. All right, let me see. Next one. Complete the table. I think you're okay with that. Standard notation. I think you're good with that. Well, what decimal part? Okay, you good with that also? All right, number 13. All right, let's have a look at it just quickly. All right, 13. A, perimeter. So the only thing that's missing is right here. All right, so what is it?
So that would be 10.
Yeah. And then add them all around, right? I think it's all
Yeah.
good there.
And then right here at the right under it, the
Oh, you mean right here? Yes.
and then
What's
that would be 20.
20? Because, yeah, because we got the whole thing, because 10 is right here, and the remaining got to be 20 to give you 30. Good job, yeah. All right. And then add them all the way around. And that will give you the A for perimeter. B, the area of the figure. Why is it the area? Are we doing volume anymore? Wait, what's happening? Unless they actually made a mistake here. Like all angles,
No, 13's perimeter and area, and then 14 is the volume.
oh, they're right. So area of this whole thing, how would you do it? Cut here or cut here?
Probably cut it like down.
Yeah, let me see. Like right here.
Yeah.
So 10 times 20 as to
Yeah, and then
10
yeah,
times 20, right? 10 times
yeah,
20,
and
two
10, 20,
times.
and 10.
Okay, good. Looks good to me. And then add those two up and then times it by, oh, is this in centimeters? Let me see. Are they in centimeters, dude? We don't know. Did it?
No, for 13,
Volume?
the dimensions are in meters, but then for 14, the height is 200 centimeters, so you have to convert that.
Okay, but where does it say it's in meter? Oh
At
yeah, you're
the
right there. Ah, I see. Well, that's fun. What do you think? Would you do a? So the question here then, would you convert meters into centimeters, or you want to convert centimeters to meters from here?
centimeters to meters.
Centimeter to meters, centimeter to meters. Okay, then let me see. How would you do that? Let's do the conversion first. Do you want to do 10 or 100, or what do you want to do to meters? 100, right? 100 centimeters
Yeah,
equals 1 meter. Is that okay?
yeah,
Yeah. Okay. I like that. So that means this will be 2 meters then. Is that right?
yeah.
All
And
right.
then it'll just be the area times 2 meters.
Yes. That looks good to me. Your teacher will accept either. Oh, no. You have to actually go by what they want. Dang it. All right. So your answer must be in cubic meters. So yeah, just in case it would be in centimeters, you have to convert the perimeter and the area in centimeters and centimeters square. Is that okay? But this one it works perfectly. So I'm glad. I thought we had to do centimeters here. That would be a lot of work. So yeah, I think this is easy. Everything's in meters, so it's all good. So this would be meter cubed. Cubed. Is that okay?
Mm.
All right, looks good. I think you're okay with that. Add them up.
Yeah.
Area times. Okay, your area will be meters squared, and then perimeter in meters here. Okay, I think you're good. Let me see what else. All right, this one, cylinder. Find the volume of the right cylinder. All right, they're asking you to do it right away. So what do you think? Oh, and then they want you to surface area. That one I have to help you here, but let's do the volume quickly. Let's set up the volume. How would you do it? 15
3.14 times 2 squared
times 2
times
squared times what?
times 5.
Yep, that's the volume. Good job. And this will be in, what is it? In cubic inches, whatever this is, cubic inches. Okay. Now, surface area. I'll let you give it a shot first because it's actually more involved. There's a lot going on here. It may be the first thing. It may be the first time you're about to see what I'm about to do here. I'm talking about if you okay. What I'm getting at is this. I don't believe your teacher knows how to actually draw the picture, like the cap being broken off and then the side being flattened out. I'm sorry, dude. I have not seen teacher done that even at high level. I know that they're actually imagining it, but drawing it is another whole entirely. I can do it. I'm not trying to brag. I've been practicing a lot for number 16. Okay, we're talking about 16. Okay, but I'll let you give it a shot first. What do you think you should do for the surface area? So don't,
3.
yeah.
3.14 times 2 squared times 2 because you need the top and the bottom.
Okay, times
And
2
then
squared times 2.
and
Good.
then yeah, and then uh
I agree. This is for
and
the top and
then
bottom. Top bottom cap.
5 uh 5 times
I'll do area side rectangle. I don't know. You can,
5 times uh 4
not quite.
or 2.
Not quite. So you get, I, I can see that you're imagining it. So it looks like this. If I actually were to break up the cylinder, it would look like this and almost flatten it. Imagine I didn't wrap it all the way around. You got the caps on top here and caps on the bottom here. See it? You already
Yeah.
got that out of the way right here. The side right here, you got 5 times. So it's like your width times the length. The length right here. How do you get that? See that? That is the circumference of the circle, right? It's the circumference of the circle. So what is the circumference formula?
3.14 times 4 divided by 2.
3.14 times, okay. Circumference is 2 pi times r or pi times diameter
Or 3.14 times 4.
times 4. You're always kind of like doing weird things with the circumference. If you can, I recommend you write this down every single time until you get really comfortable, like the circumference formula. Get it? So it's times 4. I'm going to double parenthesize this. I don't know. I'll go ahead and do that and times 4 outside. Is that okay? Like that? Is that okay? This will represent the circumference or the length right here when it's unwrapped or kind of like flattened down, and then times 5. Like I'll call the 5 the width times the length. Is that okay? So all of this, don't forget you multiply straight across. Okay, 20 times or 20 times 3. Then add them up. Do you agree?
Mm-hmm.
That's it. And then the unit for this one will be inches squared. Do you understand? You okay?
Yeah.
Look at that. See the drawing? Like I said, I've not seen teacher drawing this, dude. I have no idea why. It's not hard. I've done a lot of it. I practiced to, help you guys visualize it. You get that right? You okay? That's it. This is actually one of the fancy ones out there. But okay, don't forget to, do the caps and then the sides here, then add them up. And you got everything. All right. Almost done here. Proportion, at least, yeah, at least the fancy ones here. All right. Set up the proportion for me. And then I think one over here. So what do you think? Number 17.
5 and 1/3 over x equals 6 over 3 and 1/6.
Okay, not quite. You want to look at it again?
Oh, so
Yeah.
it would be uh
Let's stick with the 5 and 1/3.
6x, or 5 and 1/3 over 3 and 1/6 equals 6 over x.
Yes. Don't forget how you eye this thing, right? It's between how many tick marks, right?
The marks,
Yeah,
yeah.
you okay? You got a 2 and a 1. That means you got to do the 2 and the 1 over here. That means over that, right? Yeah. I know you know it, but you have to look carefully. That's all. Is that okay? Yeah, you got this. This is it, and just cross multiply. Yeah, you got it. Yeah, be careful. They're gonna trick you like this from now on, right? This one they face each other, but they're still similar triangles, but they face each other. You see how the pointing towards each other, the three tick marks there. So careful. So anyway, this looks good to me. Right now over here, there seems to be something new. I don't know. No, not really. But tell me what is the final answer for 21?
4 over
12? 12 times 12 is 144. But then we'll
yeah
have to reduce. We can do one more, right? Four.
is 2 over 6, which is 1 over 3, so 1/3.
Okay, but you can do faster than that because 4 can go into 12 three times itself one time,
Yeah.
right? Yeah, don't forget your column 4. Yeah, 4 can go into 12 three times and itself one time. Yeah, it's okay, half and half and half it. But when you get a chance, you want to force yourself to go beyond that because there's nothing wrong with it. It's just that you spend it 1 second longer. 1 second longer, dude. That's not good enough. By now, I know, just, but you get it, right? Any little precious time can help you actually, you can add them up for later on. Yeah, to me, this is faster than having it because you're writing more than what you should. I don't even think you need to write the slash. Just go write 1/3. Get it? You know what I'm saying, right? Yeah. So the time you spend writing the other half, like, and then the final answer, you already spend at least 1 or 2 seconds doing that, or 3. But if you do a lot of them on a test, whatever, that, yeah, if you ever wonder how some of your classmates are like, can do it pretty fast. Yeah, they do whatever necessary that they know, like not the trick math or anything. It's just that, yeah, they know, sometimes trick math, but yeah. But I think this is one of the things that they can do to speed things up. I think you're good for the rest. Make sure you do the order operation, like inside the parenthesis and all that carefully. What about 29 here? 4/5 of a hound dog were schleppers, whatever that is. If there were 60 schleppers, how many? Oh yeah, 29. Tell me how to do this, and we'll call it 4/5 of a hound.
4/5 times x equals 60.
Okay, so what are you letting x equals to? What x represent?
The dogs, the schlepper things.
Schleppers. Okay, schleppers. Let me double check. So this is declaring or defining the variable. Okay, when you write like x equals something, some teacher want you to start doing that. My students, my other one, they have to do it, and I can show you all that letting quickly. Let me show you that right now if I can find it. See, there's a let right here. You see this? There's a bunch of let right here. That's defining the variable. See this? The student are doing that now.
Mm-hmm.
See that? I don't know. Your teacher been actually, kind of enforcing you guys to do that now, but I think you can, if not, at least know what the unknown that you made up to represent. Let me double check here. You said 4/5 x, which is the slippers. If there were 60 slippers, how many hound dogs were there? Wait, is this right? If 4/5 of hound dogs were slippers, 4/5 of hound dogs were slippers. 60 slippers. Okay. Actually, this is not true. The X. Do you want to think about it? The
So
with slippers.
4/5 times 60 equals x.
Okay, I still agree that the equation is 4/5 times X unknown equals 60. I still agree with that. But the X is not slippers. What do you think the X is that you're trying to find? There are different type of hound dogs, right? The one they're talking about right now is slippers, but the generic number of hound dogs is actually more than 60. Do you get that from reading this? I don't know if you do, but read it carefully. Just like think grammatically, okay? Like break it down. 4/5 of hound dogs. That means hound dogs. Something about that group seems like there's more, but there's something specific in there that's called slippers, whatever, right? If there were 60 slippers, how many hound dogs were there? That means hound dog is actually a bigger generic group. Get it? Slipper is more specific. Therefore, they're giving you the specific number for the slippers. That means there's more other hound dogs. So you're solving for that. So X is what?
X is 60.
No, what is the unit? What is the unit for X?
X is the hound dogs.
The hound dogs. Because the 60 is specifically for schleppers, hound dogs. Get it? But therefore, they're asking you to find the overall hound dogs. That's other breeds involved in there. Get it? Read it carefully. So yeah, this is it. So the X is trying to find is the total number of hound dogs they're referring to. So yeah, so it's not specific. So this is slippers, but X is something else. This is slippers here. This is the hound dogs. So you're solving for the hound dogs here. The total number of hound dogs. All right. So if you solve for it, it will be bigger than 60. And that's what they're asking, right? You see how they're saying it? I hope you're okay with that. Reading carefully, that's the way I see it. I'm pretty sure I'm right. So 4/5, let's multiply the reciprocal. Times 5/4. 5/4. X equals 4 can't go into 60. How many times? 12 times. Is that right? No. 15 times. Itself one time. Anyway, 15's 4 times, that's 60. 60 plus 15, that's 75. So the answer is 75. Let me double check. Yeah. So that's it. 60 divided by 4. Yeah. Okay, that's it. So this should be the answer. This is the 75 hound dogs. So 60 of them, which is 4/5. That's a lot. That's like almost all of it, right? 4/5. 4/5 of 75. That's why it's 60. There are many schleppers, hound dogs in there in that group, but there are other type of hound dogs as well. So this is like the total number of hound dogs in this group that they're referring to. But they're giving you a. Hey, are you okay with this one? I'm pretty sure this is it. So anyway, that's 29. Okay, make sure you have all that down. You can copy it. That's it.